Okay, class, this is video 3 from Chapter 5, Section 3. If you have not already watched videos 1 and 2, remember to go back and watch those first. These problems are slightly more complicated. Okay, the instructions say we can evaluate products and quotients of really small or large numbers much more easily with scientific notation. So if you notice the first example, that looks like a little bit of a bear of a number. 1.32 times 10 cubed times the quantity 2.78 times 10 to the fourth power. Remember, we learned way back in chapter 1 that multiplication is both commutative and associative, so I don't have to multiply in the order that they gave it to me. I can pick a different order if I think it's going to be easier. So I'm going to say 1.32 times 2.78, get the number parts first, and then times 10 cubed times 10 to the fourth power, because I can certainly handle those power parts quite easily. I learned in class today that if my base is the same, I add my exponents. So that's going to be times 10 to the 7th. So now all I need to do is multiply 1.32 times 2.78. I'm assuming you're going to go to your calculator for that, and when you do, that's going to give you 3.6696. And that's your answer, 3.6696 times 10 to the 7th, because I have a number between 1 and 10 times 10 to some integer power. So all I did to make that problem a little bit easier was move my powers of 10 next to each other so that I did not have to do that multiplication and get bigger numbers there. Okay, when I move down to the example immediately below that, well, no, let me do that first example since I have both a positive and a negative exponent here. So let me go ahead and work that. This is going to be 5.21. Again, I'm changing the order because I'm allowed to do that. That's the commutative and associative property. Commutative, remember, says I can change the order, and associative says I can group it any way I want to. So then I'm going to multiply times 10 to the fourth times 10 to the negative sixth. The fact that one of those is positive and one of those is negative does not alter what I do. They are the same base being raised to a power, so the rule is add those powers. 10 and negative 6 is negative 2. That gives me 10 to the negative 2. When I multiply 5.21 times 2.55, I get 13.2855 times 10 to the negative 2. Now, do I have a number in scientific notation? I'm glad I went back and did this example. I don't have, because 13 is not a number between 1 and 10. So the next thing I have to do is take 13 and change it into scientific notation. So I know that my decimal point is here and it needed to be there. So that's going to be 1.32855 times 10. It was a number bigger than 1, so the power that I multiply it by is positive, times 10 to the negative 2 that I already had. So now I have to combine those like bases again by adding those exponents, and my final answer is 1.32855 times 10 to the negative 1. So, of course, since that's times 10 to the negative 1, my number is actually going to be less than 1 when I'm finished. Okay, now let's move down to the division. I've got 3.22 times 10 to the fourth over 2.13 times 10 squared. Again, I can not do that exactly in that order if I want to. I can take 3.22 and divide by 2.13. Now keep in mind, I can't just willy-nilly change the order any way I want to in division. Okay, but I can turn this into two separate pieces, and that's 10 to the fourth over 10 squared. Well, 10 to the fourth over 10 squared I can certainly do. That's 10 squared. What's the rule? Subtract my exponents. And my division of 3.22 by 2.13 gives me a long number, 1.511737 times 10 squared, and that is in scientific notation because it is already a number between 1 and 10 times 10 to some power. Okay, when we do the next one, I'll go ahead and do that too since there's a negative exponent involved there. First I'm going to do 7.66 divided by 4.22 times 10 to the negative 2 over 10 to the 7. Remember, the rule is you can take a negative exponent and move it to the bottom of the fraction bar to make it positive, or I can use my quotient rule that says subtract the top exponent by the bottom exponent when your base is the same. So 7.66 divided by 4.22 is 1.815165 times 10, and the power here is negative 2 minus 7, which gives me negative 9. I didn't want to move it to the bottom of the fraction bar because I want 10 raised to some power, and in this case, in scientific notation, I don't care whether that power is positive or negative. In our lesson today, just using exponents, we wanted our answers always to be left with positive exponents, so sometimes they had to be in the denominator of a fraction. Scientific notation, that's not an issue for us. We're allowed to have a negative exponent in our final answer. That tells us what direction to move our decimal point in, so a negative exponent is fine as an answer. Okay, you try those last two, and I'll come back with one more video on how to do some of this on your graphing calculator. Be sure to watch that last video.